Hi, welcome to my OOPS session. In the past OOPS sessions, we have discussed about encapsulation. Second, we have discussed abstraction. And today we are discussing the third topic in object oriented programming principles inheritance. Followed by inheritance, we are having polymorphism, that followed by message passing. So, these are the topics in object oriented programming principles. So encapsulation is completed, abstraction is completed, then now we came to inheritance. Inheritance is one of the major use of class in object-oriented programming. But compared to instantiation of class, inheriting from class is little less often. So we'll see when to go for inheritance, that in the following slides. So by definition, inheritance mechanism deals with deriving one class from another class. Suppose if you extend from an already existing class, if class B extends A, if class C extends B, if class D extends C, if a class derives from an already existing class, then that is called as inheritance. So, what is the main use of inheritance? What is the main use of inheritance? In my view, uh, we can go for inheritance in three occasions. One is, for example, if class A is already having 10 methods, if class A is already having 10 methods, and what we want to do is the 10 methods are written a couple of months or years ago. We want to add some extra methods to the existing methods of class A. When by the time when class A is implemented, its methods are written to store and retrieve the information from the SQL database, let us assume SQL database, like Oracle or SQL Server or MySQL database. Now the current trend, now the current trend from the business perspective also is to store the data into NoSQL databases like MongoDB or any of these NoSQL databases are not being used much in the market because of one reason. Yesterday I told you, whenever the relationship between our tables are less, if relationship is less, and from record to record, if the record structure want to be different, hmm? But whereas in RDBMS, all the records in a table must follow the same structure of column names, columns, the data types, their constraints, everything should be followed. But whereas in NoSQL database, from record to record, slightly we can alter the structure. Because of this no relational and no structure, most of the developers are going for NoSQL databases to store the data. But if the data is having plenty of relation between the records in the table, and if the data is structured, no doubt SQL is an option. Let us assume we are working in a database development team. So around some 5-10 years ago, there was a class written with 10 methods which are interacting with SQL database, maybe Oracle or SQL Server or DB2 or MySQL. Now to those existing 10 methods, we want to add a couple of methods to perform operations on MongoDB database also. In addition to the already existing methods, I don't want to write completely a new class with new methods. I can write one more class with 5 methods that will interact with the NoSQL database, NoSQL database. But I want to make use of the previously existing 10 methods. Plus, I want to add 5 more methods to interact with NoSQL database. So what immediately I'll do is I'll let class B extends class A. I'll add 5 methods here. 5 methods. So altogether, how many methods that class B contains? 10 methods coming from A and 5 methods belong to B. Altogether, to the clients, B claims that I'm giving 15 methods. So is this not code reusability? That in addition to the existing 10 methods, we are adding 5 methods more and making 15 methods so that if anyone uses this class B, can insert data into both SQL database and as well as NoSQL database of this particular entity, like it may be an employee or student or something. So, and this is called as, one is we are getting reusable code, and second one is we are extending by adding new functionality to class B so that to interact with the NoSQL database. Hmm? And to the clients, all over, we are providing class B is available to perform any SQL or NoSQL database operation. So clients feel easy to use a single class for you know inserting and retrieving, updating and deleting data of employee into both SQL and NoSQL database at a time with a single class instance. So this is more useful for the clients. So this is one place where we can go for inheritance. So we want a reusable and the already existing implemented methods what will be available into one more class, and there we want to add some more new methods also. Whenever we want to extend the functionality, and sometimes we want to override the functionality also. Out of these 10 methods, all some around we found that 8 methods are working fine, and 2 methods are having some problem with the performance problem due to because of more of using joins or subqueries or like that. Out of 10 methods, all 8 methods are working fine. 2 methods we found, their performance was little bit poor. We made some changes into the database so that those changes want to be made into only 2 methods of out of 10 methods of class A. And I am interested to rewrite 2 methods of class A. 2 methods I want to override because those methods are performing little bit weaker. So that we made some changes in the database so that according to that we want to rewrite 2 methods out of 10 methods, 2 methods of class A in class B. And the 2 methods we want to override and 5 new methods we want to introduce. So altogether, how many methods available in class B is 10 plus 5, 15 only. But 5 methods extra added here. 2 methods of superclass are overridden here. And the 8 original implementations of class A, 2 recently overridden method implementations of class B, and finally 5 newly included methods of class B. Altogether 15 methods are available here. And client who are using this class B can use latest 2 methods, the already existing 8 methods, plus 2 new methods of class B also. So this is how we decide whether we want to go for inheritance. If you want to add new functionality to the already existing functionality, or if you want to override existing functionality, we will go for inheritance. Add new functionality, add new functionality, or override existing functionality. Keep these two in mind. But if you want to use a functionality, then don't go for inheritance. Go for instantiation. Go for instantiation and object creation. If you create object of a class, you can call the functions of a class instead of adding new functionality or overriding existing functionality. See, whenever you are writing a program in Java or any object-oriented programming language, what you must keep in mind is whenever I am using a class, I must decide whether I want to make use of the already existing functionalities of a class or we want to add new functionalities or make some changes to the existing functionalities of a class. Based on that, we have to choose whether to go for inheritance or instantiation. So in Java, we had so many examples where we need to write classes deriving from their already existing classes in Java API. In Java API, there are so many classes exist in the JDK rt.jar file. Around some 17,000 plus classes I had in JDK. So in so many classes exist. One main important package is java.lang. So in the java.lang, the main important classes are all wrapper classes: byte, short, integer, long, float, double, character, boolean, string, string buffer, string builder. These are all wrapper classes. Plus a couple of tens of exception classes available, exception and runtime exception classes. Then next thread class and runtime class are available, and the next system class, runtime class, like object class, like you'll find so many number of major number of classes used in the core Java programming are all coming from Java dot one package named Java.lang. So from that Java lang package, I'm giving some examples here. Suppose if in Java I want to write my own wrapper class. See, in Java, for every primitive data type, one wrapper class exists in Java API. For byte, cap letter, byte, B cap letter, class, byte class. For short is cap letter class. For int, integer class. For long, long class. For float, float class. For double, double class. For character, character class. For boolean, boolean class. The next string buffer and string builder. Okay, string buffer, string builder are not wrapper classes for primitive data types, are also user defined data type classes. Okay, secondary data types. So for every primitive data type, one wrapper class exists in Java API. All these classes are derived from one super class called number. And in Java, all wrapper classes except this character and boolean, byte, short, int, long, float, double, the wrapper classes are all extended from one superclass called number. Because number class provides some common functions that are common to all these classes, like byte value, short value, int value, long value, float value, double value. So these 6 methods are required from byte class to double class. 6 classes, all 6 subclasses needs those 6 methods. So instead of rewriting those methods in all the 6 classes, those methods are once defined and given in number class. They're commonly available to all the 6 subclasses. 6 into 6, instead of writing 36, only 6 methods implemented a number made that count available as a 36 methods. Simple. Similarly, even if we want to write our own new data type and new wrapper class on our own, maybe in future for any customer requirement, then our own data type, own wrapper class. Then from which class we need to extend from? We need to extend from the number class. And if it is a numeric data type, if it is character, boolean, or string type, that's a different case. And if we want to write our own wrapper class, we need to extend from a superclass called number that exists in Java.lang package. The next, in Java, to implement threads, there are two ways of implementing threads. One is by extending from thread class, and you write one class that extends from thread. You write one class that implements runnable. Anyway, in threads, we'll discuss this topic. In Java, we can implement threads in two ways. One is by extending from thread class, and other one is by implementing from runnable interface. Which one is better, and extending from thread is more useful, or implementing from runnable is more useful? When to use which one, the occasions, all we'll discuss in the threads topic. But if you want to write our own user-defined threads, we may either extend from thread class or may implement from runnable interface. There also, we'll write a class that extends from superclass. To write threads, we need to derive from the already existing thread class. Similarly, we are having two types of exceptions in Java: checked exceptions and unchecked exceptions. For checked exceptions, we need to extend from exception class. For unchecked exceptions, we need to extend from runtime exception class. And it is too early to discuss about these exceptions and thread classes at this moment. But if you want to write our own exceptions, we may extend from exception class or runtime exception class. There also will be for inheritance. We will extend from the existing classes, already existing classes. Similarly, collections. If we come to collections, the three main interfaces are list, set, and map. List, set, map. So for the list, set, and map, already some predefined classes are there. Array list and linked list are there for list. And hash set to trace set to hash map, hash set hash set to tree set to hash set. Classes are there for set interface. For map interface, hash map, tree map, hash map. Classes are already there. So if you want to write our own lists of class or sets of class or maps of class, even then in that case also we need to derive from those list set map interfaces or their immediate subclasses, abstract list, abstract set, or abstract map. We will mostly extend from abstract list or abstract set or abstract map. So even in the collection programming also, if you want to write our own user defined classes, we need to extend from their already existing classes. Next, coming to the user interface programming. The user interface programming, I told you so many components are there. Label, text field, text area, checkbox, radio button, drop down box, button, scroll bar, and etc. etc. A couple of tens of classes are there. If you want to write your own class, like we want to repeatedly generate one login form. So every time you write one class, public class login form extends frame, and then two labels, two text fields, two buttons, and then aligning them properly on the screen, frame screen. So instead of repeatedly writing a login screen every time in every application, you can make that login component as user defined component that contains so many labels, text fields, and buttons, which are essential for every login. Login is the common functionality for every application, right? So you can write login as a one predefined component, and that component you can incorporate in every project, every user interface project. So like that, you can write your own component. If you want to write your own component, then you need to extend from component, or you need to extend from container, or you may need to extend from frame. In Java, I'm talking about. So like that, inheritance is common in user interface programming. Minimum the main screen class need to extend from frame or panel or from some superclass. Similarly, if you want to write our own user-defined driver classes in JDBC, in Java Database Connectivity, if you want to write our own JDBC driver classes, there also you need to go for inheritance. All JDBC driver classes must derive from driver interface. Connection statement, provide statement, callable statement, rel set interfaces, from which our own user-defined classes must be derived and those interface methods must be implemented. And to write driver implementation, we need inheritance. Even to write our own user-defined servlets also, we need to extend from generic servlet or HTTP servlet. And within Java programming itself, right from the lang package you start. If you want to write wrapper classes, if you want to write threads, if you want to write exceptions, if you want to write collection classes, if you want to write user interface components, if you want to write the next JDBC applications, if you want to write servlets, everywhere we write a class that extends from their superclass. We'll get some functionality, some recognition, then we'll use it in our application. So anyway, as a course of the entire course Java, you will come across all these topics, exceptions, threads, collections, UI, everything. Database connectivity, server programming, everything. So next, coming to some important points about inheritance. If a class methods want to be available, if a class methods want to be available as our class methods to outside classes, and for example, as I previously told you, class A is having 5 methods, class B is having 10 methods, 5 methods. Class C creates object of B. With the help of B, B can give access to 5 plus 5, 10 methods. How come B is claiming that I'm having 10 methods? Because it's having only 5 methods. 5 methods are coming from class A because of inheritance. So if a class methods want to be available, as our class method to outside classes, and for class C, apart from these 5 methods, these 5 methods are also available as a class B methods because of class B extends from A. Because of inheritance, all class A says my all methods are available as your methods. Deriving doesn't mean that those methods will fall into B. Whenever we create a memory for B class, the memory will also be allocated for class A. A class methods memory will exist in A class memory. B class methods memory exists in B class memory. Memory will remain on their own instances, but with this help of this B object reference, you can access both this memory and as well as this memory. Both the memories you can access. Your parent memory address also your subclass memory contains, so you can access both of them. So if you want to rewrite the functionality of a superclass methods and subclass method overriding. Or if you want to add additional functionality to the existing superclass methods, then also we'll go for inheritance. These two: rewrite functionality, add additional functionality. This we already discussed. And here is one more important point written. In inheritance, superclass properties and behaviors are available as our class and methods, our class variables and methods. In inheritance, superclass properties and methods are available as our class variables and methods. Of course, if there is any redundancy of properties or methods, and for example, class A is having a variable called A and a method name called print, and class B is also having one variable called A, having one method called print, and there is one method called write in class B. In this class B, knowingly or unknowingly, what happened is in class B we extended from class A. Class A variable and print method are available. Knowingly or unknowingly, B class is also intended to declare one variable called A and wrote one function called print. And the same variable name, same method exists in both superclass A and subclass B. So that is written unknowingly, or maybe there may be some force that we need to write variable and method like this in the class B. So what happens? Is it true? Does it work? Yes, because superclass variables and superclass methods belongs to its own memory. B class variables and methods belongs to its own memory. Now, being in the right method, user-defined method in class B, I want to access superclass variable and superclass method. What should I do? So there is one keyword available called super dot a variable, super dot print method. Sure. Superclass variable and method. Suppose if from the right method, if you want to call the same class variable and name and method, you write this dot a and this dot print. And this is used to access current instance variables and methods. Super is used to access superclass instance variables and methods. So with the help of this and super, we can differentiate whether we want to access same class methods or superclass methods. So that is one facility available in the inheritance. Now, just so far we have discussed about why when to go for inheritance. So to rewrite the functionality of the already existing superclass methods, or we want to add additional methods, we will go for inheritance. Now we'll come to types of inheritance. Coming to the types of inheritance, actually Java supports only one type of inheritance, that is multi-level inheritance. If you look at only multi-level inheritance example and leave, you can get into the Java remaining concepts. But as we came to the context of discussing inheritance, we'll discuss all types of inheritances. Inheritances are 5 types: single inheritance, multi-level inheritance, multiple inheritance, so hierarchical inheritance, and hybrid inheritance. So what does it mean? Single inheritance. See, we'll see with an example. For each type of inheritance, I've given one diagram. Right side, the diagram is given, and here is one source code is also given, and some explanation is given here. So next here, if you come to single inheritance, in single inheritance, subclass or a child class or a derived class inherits from only one parent class. Okay. And then only class B extends from A. No subclasses exist, no superclass exist. Only one subclass, one superclass. In single inheritance, subclass or child class or derived class inherits from only one parent class. Only one parent class. Properties or variables and behaviors or methods thus enable reusability and as well as adding new behaviors and modifying existing behaviors. That is what generally briefly told about inheritance once again. In inheritance, child class must point to parent class, but not parent class points to subclass. So while representing in UML is one of the visual modeling language for software engineering. UML stands for Unified Modeling Language. It is one of the languages used in the software engineering to represent, right from software requirement to till how the source code existed. Everything will be represented in this UML. It's called as visual modeling language. So in the visual modeling language, whenever you write, suppose if you write class directly, you write class B extends A. Developer can understand class B extends A. Class B extends A. This is the syntax in Java. If it is C sharp, if it is C++, what about C sharp? What about C++? What about Smalltalk? What about Python? Python also supports object-oriented programming. What about PHP? PHP also supports object-oriented programming. What about VC++? It's also object-oriented programming. But not only Java, even VC++, C Sharp, C++, Smalltalk, PHP, Python, and there are many other languages like I believe Angular uses that action script or something. That is also object-oriented programming. And in the mobile, we use Java. We use some other language also. There is also an object-oriented programming. Objective C. There is also an object-oriented programming. So, irrespective of Java or C++ or VC++ or C Sharp, if class derived from some superclass to represent, what to do is, because we don't write source code, right? Because source code is specific to the programming language. In UML, we use one visual modeling diagram called use case diagram. Not use case diagram, sorry, this is class diagram. Class B, we say extends class B. They will write one empty triangle head pointing to superclass followed by a character. Class, we say class B extends A. We don't say class B is derived into B. Because even in the programming also, subclasses knows about superclasses, but no superclass knows about subclass. Remember, every subclass knows about one or many of its superclasses, but no superclass knows how many subclasses it contains. A superclass can contain any number of subclasses, uncountable number of subclasses. So no superclass knows the subclasses count, but subclass knows superclasses count. So we should represent like this: solid line with an arrow triangle tip pointing to the superclass. That is what inheritance representation is. In Java, if you want to write a code for that, you write class A, you write some methods, variables and methods. Then you write class B extends A. Extends A. Finish. You add some variables and methods here. So this is single inheritance. Only one subclass, only one superclass. Right, next. Coming to the multi-level inheritance. Java supports only multi-level inheritance. Java supports only multi-level inheritance. We'll find out the reason why Java supports multi-level inheritance later on. It has some ambiguity problems that exist, so that we'll discuss later. How multi-level inheritance is. In multi-level inheritance, each subclass derives from only one superclass at a time. Each subclass derives from only one superclass at a time. D extends from C, C extends from B, B extends from A. That superclass again derives from only one or more superclasses at a time. That superclass again derives from only one more superclass at a time. Okay? Each class derives from only one superclass. That class again derives from only one superclass. That class again derives from only one superclass. Deriving from only one superclass, like that, the hierarchy grows. It's called as multi-level inheritance. In UML, we'll represent like this. Actually, this is not UML representation. A solid line with a triangle, halo triangle tip pointing to superclasses, what called as inheritance symbol. We call it as extends. In Java, if you write the source code, class A, class B extends class A, class A extends B, class D extends D extends C, C extends B, B extends A. A superclass is object. This is multi-level inheritance. Coming to the multiple inheritance. This is multiple inheritance. In multiple inheritance, a subclass can derive from more than one superclass. A subclass can derive from more than one superclass. Each such a subclass we call, but for us it's a superclass, may derive from some more superclasses. So this is how the diagram exists. In multiple inheritance, each subclass can derive from any number of superclasses. A subclass can derive from any number of superclasses. Such each superclass can again derive from any number of superclasses. Such each superclass can derive from any number of subclasses. See here, D derived from A, B, C, A derived from A1, A2, A3, B derived from B1, B2, C derived from C1, C2, C3. And altogether you tell me, you see how many superclasses A is having? 3, B 2, C 3. Altogether how many superclasses D is derived from? 3 plus 3 6 plus 3 9 plus 2 11 superclasses. 3 3 is 9, 3 3 3 9 plus 2 11 superclasses. And within two levels of hierarchy, class B D is derived from 11 superclasses. Now, is it an advantage or disadvantage? So, every type of inheritance is having its own advantage and disadvantage. So, the one advantage of multiple inheritance is more inheritance, so that more variables and more methods comes in a short period of time. Within a short period of time, class D comes with variables and methods of almost 11 superclasses. Apart from its own methods, 11 superclass variables and methods will come at a time into D. So, more reusable code comes into D within a very short time. That is one advantage. And coming to the disadvantage of multiple inheritance is more complex hierarchy. And one day if you ask, who are your parents or grandparents? Tell me about your family tree hierarchy. Class D can tell up to 1 or 2 levels, not beyond that. Because if A1 derives from 3 more superclasses, A2 from 2, A3 from 4, B1 from 2, B2 from 2, C1 from 3, 4, 2, 3. Tell me. How many classes D has been derived from the second level onwards? So, it is out of imagination. So, hierarchy is so complex. And, okay, fine, forget about hierarchy. We hardly remember only up to 1 level and 2 levels of hierarchy. But that next level of hierarchy is quite impossible to remember. That is one drawback of multiple inheritance. Hierarchy, superclasses hierarchy is very complex. Second one is, if at all if you create object of D, in comparison with what you call multiple inheritance, multi-level inheritance is far better from memory consumption point of view. Suppose if you create object of D, as you already know that in every class constructor, superclass constructor calling is a common statement, isn't it? I'm talking about multi-level inheritance, not multiple inheritance. So what does it mean? Every child class constructor will call it superclass constructor, that superclass will call it superclass constructor, that superclass will call it superclass constructor, and superclass constructor calling will go on from child class to superclass like that. Memory calculation starts from superclass to child class, and finally to the new operator. Child class constructor will tell, okay, my entire hierarchy, my whole family of all my class, my superclass, it's superclass, all together we want some 250 bytes or 300 bytes of memory. New operator will allocate memory somewhere, that address will be given to object reference. The point is, if at all if you create object of D, the memory required for D class variables and methods, ABC class variables and methods, A1, A2, A3, B1, B2, C1, C2, C3 class variables and methods memory, to all their instance variables, memory will be allocated except to the static variables. Imagine the situation. If at all if you casually create one object of D, memory will be allocated for its class, for its superclass variables and methods, to its superclass variables and methods also. So imagine how much memory occupation takes place here, how much unnecessary memory gets wasted here. After all, to call one method of D class, so method 1, you created so much of big queues. Here memory exists for D, memory exists for ABC, memory exists for A1, A2, A3 instances, B1, B2, and C1, C2, C3. What is this? These are not variables. These are the objects for which the memory is allocated along with D. The memory wastage is very high in case of multiple inheritance. And there's another point, the same point which we are discussing here. During multiple inheritance, there is one more disadvantage. That disadvantage is superclass variable or method ambiguity problem. Superclass variable or method ambiguity problem. The problem comes like this. Suppose we are having class A. The Java don't support multiple inheritance. Suppose if supports multiple inheritance. If any language supports multiple inheritance. In class A, we declared variable A. In class B also, we declared one variable B. In class C also, we declared one variable A. Here I am writing print method. I want to call my class variable, A variable. How should I call this dot A? So suppose from C, I want to call superclass variable. For it, print super dot A. In multi-level inheritance, each class is extends from only one superclass. In multi-level inheritance, that is what Java supports. In multiple inheritance, a class extends from more than one superclass at a time. Now, in this case, from child class, and there is one method from the child class. If you want to call super.a, both A class is our superclass, B class is also our superclass. In both the classes, A variable exists. So, from where this A variable should be taken from? Is superclass A variable is ambiguous or not? First, super means which class to point. Second, A variable is available in both the classes. From which class the A variable should be taken from? Finish. So this is variable ambiguity problem. Such ambiguity problem exists with the methods also. So due to multiple inheritance, variable and method ambiguity is quite often complexity of hierarchy, more wastage of memory, or are the disadvantages of multiple inheritance. Advantage is within a short time we'll get more number of variables and functions into our class. This is briefly about multiple inheritance. If you look at the code, class D extends A, B, C. Java don't support. Other languages may support. Class D extends A, B, C. And the next class D extends from B, B extends from B1, B2. Class D extends from A extends from A1, A2, A3. Class D extends from C extends from C1, C2, C3. Like this is how we'll write the code. This is hierarchical. One parent node, two leaf nodes. The next again, two or more leaf nodes. Again, two or more three leaf nodes. More leaf nodes like this. This is how hierarchical inheritance exists. Class A, class B, class C, class D. All three will derive from class A. So each class is deriving from only one superclass. B extends A, C extends A, D extends A. Here, B is derived into four subclasses. B1 extends from B, B2 extends from B, B3 extends from B, B4 extends from B. And we will see the example. C1, C2 both are derived from C. D1 to D4 are derived from D. Both A, B, C, D are derived from A. So we'll write like this. Class A, class B extends A, class C extends A, class D extends A. The next coming to B1, B2, B3, B4. B1 extends B, B2 extends B, B3 extends B, B4 extends B. Similarly, you write for C1 extends C, C2 extends C, D1 extends D, D2 extends D, D3 extends D, D4 extends D. Like that you write number of classes. So it looks quite opposite to multiple inheritance. In multiple inheritance, one child class derives from many superclasses. In hierarchical inheritance, one parent class derived into many subclasses. That is natural, one parent class can derive into any number of subclasses. No parent class knows that count. Hierarchical. And coming to the hybrid both B class and C class derived from A. D extends from both B and C. D extends B comma C. B extends from A. C extends from A. So this is called as hybrid inheritance. It's a combination of both hierarchical and multiple inheritance. Remember, in Java supports only multi-level inheritance. Hence, in Java, each class can derive from only one superclass at a time. Here is one beautiful example on multi-level inheritance. If you look at this code carefully, left hand side I've written three classes: class A, class B, class C. Class A, class B, class C. So in class A, we are having only one method called word M1. Some system dot dot that will tell M1 of and M1 method of A class called. Like that one message was written. Class B extends A word method M2, SOP M2 method of B class called. Class C extends B, B extends A, C extends B. C extends B, M3, SOP, M3 method called of class C. So each class is having one method. Up to A, there is only one method M1. In B, we are having both M2 and M1. In C, we are having M3, M2, M1. And C class is having three methods. B class is having two methods. A class is having one method. Because all parent class methods and variables can be accessed through child class reference. So availability is three methods available in class C, two methods available in class C, one method available in class A. Now coming to the client, see the client how interesting it is. Right side if you carefully observe, here I created object of A, new A of, created object of A and taken the reference into A. A class object created, A class object created. A reference taken into A class reference. Do I need to tell this? That specifically, yes. A class object is taken into A class reference, where A class object can be taken else. A class object can be taken only into A. B class object can be taken into B and A. C can be taken into C, B and A. So we'll see the difference. So if you create object of A and take the reference into A, you can access only M1 method. Good. Now, if you create object of B and take the reference into B, B class object is created. The reference is also assigned to B class reference only. And then now, both the M1 superclass M1 method and M2 method both are available with the help of B reference. Well, object is created for B and taken the reference into B, so both M2 and M1 methods are called. And then next, in this statement, C class object is created, reference is taken into same C class reference. All M1, M2, M3 methods can be called. So there is no surprise in knowing about these statements, because A class object if you create only M1 method can be accessed. B class object is created, M1 M2 both methods can be accessed. And if C class object is created as per this diagram, both M1, M2 and M3 methods can be called. But the point in multi-level inheritance, observe it carefully here. This statement is very, very wrong. Assigning superclass reference, remember always, assigning superclass object into subclass reference is always wrong. Superclass objects cannot be assigned to subclass. Subclass objects can be assigned to superclass. Is valid. That means A is equal to new B of or new C of. Anyone is correct. B class object can be created, a reference can be taken into A. C class object can be created, its reference can be taken into A. But A class object cannot be created and taken the reference into B or into C references. This is absolutely wrong. Subclass, superclass objects cannot be assigned to child class references. A child class objects can be assigned to superclass references. This is valid. Now, keeping that in mind, here I'm trying to create object of A and taking the reference into B. This is absolutely wrong. We immediately get a compilation error saying that superclass object reference assigned to the subclass reference. That is wrong. it can compiler immediately gives an error. Okay. So what we did next? Here B class object is created. Previously B class object is created and taken the reference into same B class reference. So both M1 and M2 methods got accessed. Now B class object is created and taken the reference into A. B class object is created and its reference is taken into A. In this case, only methods which are common in both class B and class A can only be accessed, but not the methods of B alone. Object created for B, but taken the reference into A. To A reference only about M1 method is known, but about M2 method is not known. Memory allocated to B2, but because the reference is taken into A, this A reference known only methods. That means only M1 method can be accessed, M2 method cannot be accessed. With A reference, if you try to access M2, compiler immediately gives you saying that M2 method is not available. Unknown method M2. Some error it gives. So if you create object of B and take the reference into A, only M1 method can be called, M2 method cannot be called. Because to A reference, only about M1 method is known, about M2 method is not known. Okay. Then coming to, you can expect the next one also. If you create object of C and takes the reference into A, C class object is created and the reference is taken into A. If you do like that, though memory is allocated to C for 3 methods, but because the reference is taken into A, only M1 method can be called. Object is created for C, but reference is taken into A, only M1 method can be called. At the same time, if you create object of C and takes the reference into B, the methods that are common in both C and B, that means C methods are not available. To B, M2 method is known and M1 method is also known. And then by creating object of C and take the reference into B, you can access both M1 and M2 but not M3. And if you want to access all the 3 methods, you create object of C and take the reference into C. Then all the 3 methods are accessible. So we need to learn this point also as very important point in multi-level inheritance. Which class object we are assigning to which class reference. Based on that, we have to determine which methods are accessed. And here is one more important point I would like to mention. Suppose if I'm calling I'm creating object of C, taking the reference into B. C class object we are creating and taking the reference into B. Okay, fine. Now with this C object, which methods can be called with this BC into B into B reference C class object. With this reference, which methods can be called? M2 method can be called. M1 method can be called, isn't it? M2 method can be called and M1 method can be called. M2 method can be called and M1 method can be called. But in this case, in class C, we have overridden M2 method. In class C, we have overridden M2 method. If I try to call C object dot M2, M2 method is overridden recently in C and original method is available in B. The reference will always take the latest reference that M2 method implemented in class C will be taken and executed. But M1 method from this class only will be executed because M1 method is not overridden here. Suppose if, I'm sorry, suppose if M1 method is also overridden here, where in class C. If called BC.M1, then M1 method implemented recently in class B, and then with this parent subclass object taken into parent class reference, wherever the method recently overridden, that implementation will be taken. That is one more very important point you have to remember. That's all about multi-level inheritance of writing class A, class B, and class C. Which object taken into which reference, what consequences we'll face, all that we have discussed in this session. And in the next session, we'll see uh, some types of classes. In Java, we are having various classes like interface, abstract class, fine class, inner class, anonymous class, and even. We'll discuss about them. So after completion of classes, we'll discuss polymorphism and message passing as a last. So in attendance, we will have one more session that we will take later on. Thank you. Bye.
Like, share, and subscribe. Hit the bell icon for more updates.